Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Now I am going to explain the chapter Periodic Classification of Elements, that is for class 10 and according to CBSE syllabus. Now here already in I have explained part 1 and part 2 where I have explained Dovonier triads and Newland's octave. Now part 3 where we will see here Mendeleev's periodic table. What is Mendeleev's periodic table? The Mendeleev periodic table till now it is existing and that is the main founder of the periodic table. That means the Mendeleev is the main founder of the periodic table. According to him, till now we are following. But here there are two types of Mendeleev periodic table. One is old periodic table and second one is new form of periodic table, modern form. That is called modern periodic table. Now we will see first the founder of the periodic table, Mendeleev, who proposed the periodic table and how that is called old periodic table. Now here classifying of elements, that credit goes to Mendeleev because the Mendeleev only that person, that scientist who discovered, who has given the idea that about our periodic table. Periodic table of elements where the elements are arranged according to the atomic mass. Atomic mass, that is similar, having similar chemical properties. He arranged the elements according to their increasing atomic mass and having similar chemical properties also. Then what is called atomic mass? Atomic mass means the mass, that is we found the weight that is related to hydrogen. How many times related to the hydrogen molecule? Hydrogen atom. That means hydrogen atom having one proton, you know the weight or the mass of the element that is equivalent to the number of protons of the element. Since hydrogen is the smallest element in the periodic table and the first element in the periodic table where the atomic number is 1 and the proton is 1, so mass also equivalent to 1. So what is atomic mass? Atomic mass means the weight of the element that is compared to the atomic mass of the proton, that is how many times of hydrogen it is related, that is called atomic mass. Now, according to the atomic mass, that is calculated. First, the atomic mass was discovered. That is why atomic mass is the important factor. Now, after that, discovering of elements, the Mendeleev only arranged how many elements? 63 elements. Only 63 elements arranged. He observed the compounds because you know hydrogen oxygen is very active. That is why he always made experiment of the elements with hydrogen and oxygen and compare it how they can be arranged. They would be arranged in the periodic table. Yes, that is why he always made experiment with hydrogen and oxygen. Hydrogen hydride, oxygen oxide. So he made the compounds and that compounds again compared to each and other elements. Most of the elements, after that he observed most of the elements out of 63, most of the elements got a place in the periodic table. And after that what to do? That means they are arranged in the order of their atomic weight. Most of the elements, 63 elements here discovered, and out of 63, most of the elements got the place in the periodic table which are arranged according to their atomic mass. That means he got success arranging of elements according to their atomic mass. Then after that what happened? The recurrence of element, he also observed recurrence of the element with similar physical and chemical properties. Suppose he placed the element the sodium in first group and potassium also first group, he observed that potassium sodium both are having similar physical chemical properties. Now how the elements are arranged in the old form of periodic table, I will say. Now, but he observed recurrence of the property. Sodium property, what is the physical chemical properties of sodium? Let sodium react with that mean here sodium is very light element, potassium also very light element. Now here Mendeleev periodic law. That means that is old form of periodic law. Remember, it is not a new form or modern form periodic law. It is old form. That means Mendeleev proposed a periodic law. What is that periodic law? The properties of elements. Remember, properties of elements are the periodic function of atomic mass. That means elements which are arranged according to the increasing order of atomic mass, and here is said that they are periodic function. Periodic function means after some interval of time, which element comes, they have the similar physical chemical properties, but also function of atomic mass. That means increasing order of atomic mass. According to the increasing order of atomic mass, the elements are arranged. He observed properties of elements are the periodic function of atomic mass. That means when you increase the atomic mass, again the new element comes to the same position if they have similar physical chemical property. That is called periodic function of the atomic mass. So what is periodic law? That is old form of periodic law. The properties of elements are the periodic function of their atomic mass. The atomic mass is the correct word. Don't use here atomic weight. Sorry. Now we will go to what are the other rules and what are the achievement of the how the elements arranged in the old form of periodic table, and how they are having same nature, same similar and physical chemical properties, how many groups he had made. So now we will see old form of periodic table. Mendeleev periodic table, that is old form of periodic table, contains vertical columns, that is called group, and horizontal column, that is called periods. Vertical column means this one, and horizontal column this one. It is called groups, and this is called period. Then what happened here, you can see R is used to represent any element in group. R means any element in the group. And the hydride of the carbon, then if you say hydride of carbon, R is the element and H is the hydrogen. And so what is the formula? CH4, or you can say RH4. R is the here carbon element. Oxide of the carbon, what is the formula? CO2. H, RO2. R means any element, there is carbon, and here O means oxygen. This is called oxide. So how can you put the old form of periodic table in here? You can see here group 1, 2, 3, 4, 5, 6, 7, 8. How many groups are there? 8 groups. It is a little bit difficult one. You can observe, but nowadays it is not existing. It is not following. And so oxide and hydride, how can you write? R2ORH. What is the meaning? Oxygen valency here 2 and charge is minus, so R2O, and hydrogen valency minus 1 RH. Similarly here second group RO means here valency 2, R is plus 2, O is minus 2, and RH2 here also hydride of the second group. Third group R2O3, where 3 is the valency of third group, and here an RH3. Similarly, this is called fifth group R2O5, where 5 is the valency of fifth group, and here R is 3. It is also valency of R is 3. So what is the formula? R2O5 RH3. Similarly, sixth group RO3 RH3. And now you can come to seventh group. Seventh group where fluorine, chlorine are there. So R2O7 RH. So here you can see eighth group. Eighth group simply RO4. Eighth group simply RO4 because with hydrogen it cannot exist, it is not existing the compounds of hydrogen with our 8th group element. Now, if you see period I told it is in this horizontal line. First period, this is group 1. Listen, group 1, first period, only hydrogen. That at that time also in all form periodic table, only one element hydrogen is existing, which is the first element in the periodic table. And if you say second period, this is the second period. So what happened? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Now also it is there, but including other elements. This is only, remember, this is only old form of periodic table, and now we are not, this is not existing as a new form of periodic table. That is totally different. So we should remember the modern form of periodic table. We should know what is meant by old form of periodic table. And now this is group 1 and B. This all the thing, all the elements are this here. This is called group A, and this is called group B. Copper is group B. So here also you can find group A, beryllium, magnesium, calcium, and B group, zinc. Then here there is third A, third B. Third A, boron, aluminium, gallium, and B is scandium. A, which A? Fourth A. Fourth A is carbon, silicon, germanium. And here thallium, that is group B. Next is group 4th, again AB. Nitrogen, phosphorus, arsenic. Nitrogen, phosphorus, arsenic. And group B, that is only vanadium. Now come to group 6, oxygen, sulfur, selenium. And others below also some elements are there. Up to here it is sufficient to know. And group B means chromium. And group 7th, group fluorine, chlorine, bromine. And B only manganese. And 8th group ferrum, or you can say iron, cobalt, nickel. Iron means Fe plus 2 ferrous, Fe plus 3 ferric, or you can say iron is English name, chemistry ferrum. What is ferrum? Iron. Iron is English name, ferrum is the chemistry name. And so, and this is called transition series. Totally here transition series are existing, and here also copper, zinc, scandium, thallium, vanadium, all chromium, manganese, all are the transition metal. So this is also here also so many transition metals are there. So it is called transition series. Again see, don't use this form of periodic table now. Only to know what is first old form of periodic table. Up to here you can write if you want, and after that leave it, because this much is sufficient for you. And again see, Mendeleev periodic table contains vertical column, that is group, and period, that is horizontal row. R is used to represent the element, and oxide, CO2 let example, and hydride let CH4, RH4, and RO2. This is group 1, 2, 3, 4, 5, 6, 7, 8. In here oxide and hydride, how the valency are used to form the oxides and hydrides. From here you can say what is the valency of group 2, 3, 4, also 1, 2, 3, 4, 5, 6, 7 and 8 leave it, and up to 7 easily can calculate what is the valency of element and how the oxide and hydrides are formed. Up to very important. And also here periods. Periods mean here you will see first period, second period, third period, fourth period, fifth period, sixth period also there. In fourth period you can see two type of series. One coming to group A and second series come to group B. Similarly, in fifth also one is group A, B is the second series. This is the first series, this is the second series. So you can remember these are the elements arranged here according to group A, group B, group A, group B, like this. But nowadays it is not like this. There are 18 groups and 7 periods. I will explain when come to that is new form modern form of periodic table and periodic law. So here, after that, up to here it is proved, that is explain how the old form of periodic table is there. But here you will see what are the achievement, what are the disadvantages. Disadvantage means how, why it is necessary to go to higher, that is new form of periodic table. So this is due to disadvantage. Again Mendeleev again proved that a new one is there, modern form of periodic table. And what are the achievement, advantage of this periodic table, you will see now. Now we will see achievement of the old form of periodic table that was proposed by Mendeleev. Mendeleev proved that one is old form periodic table, another is modern form of periodic table. On basing of achievement and disadvantage or limitation of the old form of periodic table, the new form, that is modern periodic table, was proposed. So first we will see what are the achievement of the periodic table, that is old form of periodic table. Actually he had to place some elements which is higher atomic weight, before that lower atomic weight. Example here, cobalt atomic mass, that is 58.9, is placed before nickel 58.7. So that means here cobalt has higher atomic mass, though it is slightly different, but it's placed before the our nickel. Now here it indicates that there is some any new word, that the meaning that should be help in future periodic table, that is atomic number. Atomic number, after atomic mass, atomic number is used in new form, modern form of periodic table. He left some gaps. Though he discovered elements and he thought that some elements were there that we can put in the periodic table. So according to his arrangement, he left some gaps to put the new discovered elements should be placed at that place. But only it is not discovered at that time. After that, some element discovered which is matching in the gaps which is present in the periodic table. He named them what he thought that in future some element will discover after the putting that old form of periodic table, and when new element discovered in that in his time or after that also, that is always is vacant at the time, and he put some word, some digit, that is in Sanskrit. In Sanskrit, eka means one. So he put, suppose scandium and gallium germanium were discovered later. What? Before putting the periodic table, here scandium, gallium and germanium are discovered. Already periodic table discovered, and in the meantime here scandium, gallium, germanium are discovered, were discovered. Then what to do? They have the similar properties. He, scientist Mendeleev, already proposed in that case some elements should be put. Then what is the name? What is the main important name of that gap element? So he put the word eka. Eka boron, eka aluminum and eka silicon. Exactly it was proved that here instead of eka boron, scandium, gallium, instead of aluminum, instead of silicon, the scandium, gallium and germanium are discovered element. So instead of that, he put the name eka boron, eka aluminum and eka silicon respectively. Are you clear? That means scandium, gallium and germanium, when he already discovered the periodic table and some gaps are there to be discovered element, and here he has done, that means here he put the name of the future discovering element as eka boron, eka aluminum and eka silicon, which was suitable to scandium, gallium and germanium after discovery. Gallium discovered later, replaced by eka aluminum, similar properties. That means eka aluminum and only simply gallium, both are same. But before the discovery of gallium, he put the name in that place eka aluminum. Are you clear? Gallium discovered later and replaced by Eka aluminium. Eka, that is Sanskrit digit, and Eka aluminium, which are similar properties with gallium, which have similar properties with gallium. That is why gallium that put in replacing, that is Eka aluminium. And there are some advantage of achievement of Mendeleev periodic table we will see now. Next point you will see achievement number 3, number 4. That means here, what about our noble gas? What about our noble gas? Noble gases like helium, argon, krypton, and other gases, the krypton, xenon, radon, they are discovered later. That means the noble gases all discovered later and very inert and having low concentration in atmosphere. That is why all the noble gas, inert gas, that is placed in another new group, but not in old group. Without disturbing old group, it is placed in a new group, that is the noble gas elements group, zero group, because it is inert, that is a zero group. Then come to limitation. What are the limitation point? Disadvantage. Actually, electronic configuration hydrogen resemble to the our alkali metals. Alkali metal mean first group. First group mean now here it is lithium, sodium, potassium, rubidium, cesium, francium. Now it is resemble to alkali metals regarding configuration. Electronic configuration lasts in one number electron, and here also in our alkali metals also one. That means according to configuration, after that you will read the configuration. Already you have done, you have read in class and chapter atomic structure chapter, that is what is the configuration of hydrogen 1 and what is the configuration of alkali metal first, that is let us sodium 281, potassium 2881. That means here you can say hydrogen similar to alkali metals regarding configuration. And what about other hydrogen combined with halogen, oxygen and sulfur? Hydrogen also combine with halogen, oxygen, sulfur. Similarly, alkali metals also combine with halogen, oxygen, sulfur. Then what to do? Hydrochloric acid, water, H2S. Similarly, NaCl. Now this is alkali metal, NaCl, Na2O, Na2S. Here what you observe, same compound is formed by hydrogen, same type of, not same type of similar compound that form for your alkali metal. Example here taken sodium. Then that is the main one limitation. Then how can you put the position of hydrogen in the periodic table? Hydrogen and halogen form diatomic molecules of H2. See here, if you say H2 Cl2, that means hydrogen forms diatomic molecule and chlorine also form diatomic molecule. That means alkali metals, halogen also form diatomic molecule and hydrogen also, both form hydrogen and halogen, both form diatomic molecule. That means sometimes it can be proved it is similar to alkali metal by this process, and sometimes you can prove hydrogen and halogen both are similar. Then hydrogen, but not in configuration but in other properties, form diatomic molecule and combine with metal and non-metal. Hydrogen also combine with metal forming hydride. Non-metals form hydrogen sulfide, hydrogen chloride, like this. Similarly, covalent compounds and could not fit the position of hydrogen periodic table. So one case is similar to alkali metal, that is first group, sometimes similar to that halogen group, then it forms diatomic molecule at form. So it is very difficult to find out the position of the periodic hydrogen in the period at that time. Not now, at the time, here it could not find the fixed position of hydrogen in the periodic table and could not explain the existing isotope. What is mean isotope? Isotope mean, I told, the same element having same atomic number but different mass number. He could not explain what is the isotope, how it exists. Now, atomic main important point at that time only atomic mass the word was discovered, but not atomic number. Atomic number after discovery atomic number, the periodic table become very easy, and after discovery of so many elements, so periodic table becomes easy. That is called modern form of periodic table. And now atomic mass never increase and never increase in regular manner, and also it is never a number, it is never a whole number, it is a fraction weight decimal. So 9.2, 3.9 like this. Here you can find atomic masses do not increase also in regular manner. Sometimes the first element is a higher atomic weight after proceeding element. So here again you see this is the limitation regarding about hydrogen though similar configuration to alkali metals, but again there is some point that how it should be placed at the first group, but because first group contains the alkali metals. But again it is proved that it is proved that hydrogen and halogen both are similar, because hydrogen forms diatomic molecule and halogen also forms diatomic molecule. It is similar to halogen. So it would be placed in the place of halogen. And also it can to form covalent compound, it forms also covalent compounds with metals and non-metals. Uh, with non-metal it forms covalent compound, hydrogen and to form, so you should write to form only compounds, nothing, to form compounds, and could not find fixed position of the hydrogen in the pit. This is the main defect, main problem, main limitation, that position of hydrogen could not be explained whether it is placed in first group or that halogen group. And atomic masses do not increase in regular manner, and that is a not a whole number, it is a fraction. So when you will read that modern form periodic table, what are the doubts in the old form periodic table, all will be clear already, will be clear automatically. So don't be confused, any doubt when reading. Actually when you read the old form of periodic table, so many doubts will be created. So don't worry, it will clear when you read modern form of periodic tables by the same scientist Mendeleev. So it is called Mendeleev modern form of periodic table, and it is old form of periodic table. What I have explained, this is called old form of periodic table. Now I hope it is clear to you. If any doubt, again it will be clear in the modern form of periodic table. Hope you will subscribe my channel BL Das Short and Sweet in Chemistry, and thanks for watching my video. Thanks again to all.